Welcome once again to everyone. My name is Henry Kerali. I will be the moderator for this session. By way of introduction, I recently retired from the World Bank after nearly 20 years serving as country director in a number of regions. Prior to that, I was a professor at the University of Birmingham in the UK, specializing in road management and finance. We have with us today Helen Platt and Ben Walker from DT Global, who are assisting with coordination of this webinar. Before I introduce our keynote speakers, I'd like to go through some housekeeping matters. First of all, live transcription is available by clicking the closed caption or CC icon at the top or bottom of your Zoom screen, depending on what you're using. Presentations will be shown during the webinar. To make a comment or ask a question, we ask that you use the Q&A feature and not the chat function. This will give an opportunity for you to comment during the presentations or to ask questions. And also some people may wish to answer them through the Q&A comment feature. Please be aware that the chat function can be disruptive for those who are using screen readers, and we ask that you do not use this function when people are speaking especially. The webinar is being recorded, and following the completion of the webinar, there will be links to the video, as well as links to the presentations that are made, and summaries of the key points that are discussed, and any actions that need to be taken. This webinar is part of the outreach activities of the High Volume Transport Applied Research Program, HVT, which I'm sure most of you know is financed by UK aid. So let's start. As you're all aware, investing in transport development is an extensive and expensive commitment for governments, particularly those in low-income and middle-income countries. To give an idea of the scale of commitment, in 2021, the World Bank had 162 active projects in its portfolio, of which 31 billion as the total cost, out of which approximately 20 billion are for connectivity or interurban and rural roads and other forms of transport infrastructure. In the pipeline, there is an additional 18 billion over the next 3 years or so. These enormous investments to build and maintain infrastructure means choices have to be made, especially these choices will be locked in for decades because the lifespan of infrastructure is counted in decades. This is particularly relevant and important in low and middle income countries where complex and huge investments are made amid rapid changing economies. It is therefore critical that decisions about infrastructure are spotted with the most robust evidence of what works and what does not, sourcing and sharing the latest data, and sharing insights into data collection methods is a cornerstone of the HVT program. This webinar will explore the power of decision systems and data to support the development of transport in low and middle income countries that meets the challenges of rapid urbanization and, of course, the impact of climate change. It will also showcase an innovative approach for collection and dissemination of data, recognizing the huge cost and logistical challenges that gathering data presents. The webinar will also highlight the latest data and modeling from one of the HVT projects, exploring how data can be used to inform adaptations for long-distance transport that is climate resistant or resilient. We now come to the main part of this webinar. We have two presentations which will be shared on the screen. As noted earlier, we ask that you use the Q&A function only to submit questions, or if you wish to make some clarifications, please use that as well. There will be a formal 5 minutes after each presentation for an exchange of short Q&A. And after both presentations, at the end, before we close the webinar, there'll be a longer session during which you can ask questions in person. and get responses from the presentations. I'm now pleased to present our speakers. Our first presentation will be by Tom Russell from Oxford University, who is working on the HVT project, Decision Support Systems for Resilient Transport, Strategic Transport Networks in low-income countries. I will leave it to Tom to highlight the key aspects of the project. This will be followed after 5 minutes of discussions by our second presentation, and I will introduce Philip Krause at that point. So over to you, Tom Russell, if you'd like to take over and share your screen. Thank you.
Thank you, Henry, and thanks everyone for joining, and thanks to the organisers for having me. My name's Tom Russell. I'm a senior research software engineer at the University of Oxford. I've been working on this HVT project for a year and a half or so with colleagues at the University of Southampton. And we've been looking at low and middle income countries in Eastern and Southern Africa. So in particular at Uganda, Zambia, Kenya, and Tanzania. I'll give a bit of an introduction to the project and then kind of focus the talk on the methods we've used for data collection, the data sources we've had, and the output in terms of a visualization tool that's freely available on the web. Let me share my screen. Okay, hopefully that's all up and clear. So, as I mentioned, we've been looking into developing decision support tools for planning climate resilient transport systems. And if there's, first I wanted to thank the project team. I'm a small part of this project. I've focused on the software and tool development. But as I mentioned, colleagues from both the University of Southampton and in the University of Oxford have been essential to the project as a whole. So if there's one thing I wanted to sort of provoke or suggest from this short talk was this quote from the UK government's Government Digital Service, where they say, "Make things open, it makes them better." I think that's a useful nudge to suggest that the work that we do can be shared broadly and can build on itself, and we can build on each other's work and collaborate much more easily when we do as much in the open as is possible, pragmatic, as is available. So let's get into the substance of the talk. Our project aims to provide transport decision makers in low and low middle income countries with decision support tools to prioritize interventions around sustainable and resilient long distance transport networks. Today, I'm going to focus on the resilient side of that. There's much more we could talk about in terms of broader sustainability, bringing in many more pillars of what a sustainable long distance transport network is. Today, we're focusing on resilience and hazards. So the framing problem, as I'm sure all or many of you are aware, is that floods and other climate-related hazards damage transport infrastructure, and that causes direct damages to roads or rail where they need to be repaired, rebuilt, rehabilitated. But it also causes much wider disruption to economy and society. So people need to get to work, to healthcare, to school, and goods need to be transported long distances through ports, between modes, road, over rail, and all of these climate-related hazards can cause quite broad disruption to economy and society. This is the single graph I'm going to show from the results of our analysis in these 4 countries, which is a little dense. So let me just annotate the 3 things I want you to notice from it. Looking at flood damages, the kind of expected damages on average in any given year, in current climate with current conditions, there are considerable damages to roads and rail in the region. In the future, over time, in a medium emission scenario, so RCP 4.5, that will increase as floods become more frequent or more intense or both. In a higher emission scenario, that change in intensity and change in frequency is higher. It's going to push damages even higher. So in an RCP 8.5 scenario, we're seeing even higher damages. So Henry already mentioned that roads and rail are crucial to economic development as these countries urbanize and develop their economies. We've also got to contend with the changing climate, which is posing increasing risks to these infrastructure networks. That's the problem. There are all sorts of things we can do about it. And one set of interventions that we've considered, excuse me, is the variety of kind of civil engineering, protection, strengthening interventions that you can make to improve drainage in all sorts of different ways, or to protect your infrastructure against flooding. So what we've done broadly is assess the risks of that flooding poses to road and rail within the countries of interest, and then as a first pass, considered the risk reduction and the cost of intervention for these kind of high level initial quantification of how these interventions could reduce those risks and provide all sorts of benefits. So how have we done this? And this is where data comes in. What we've done is use global open data sources, and there are two that I particularly want to highlight. There are many others we could talk about with longer, and maybe that'll come up in the questions. But for this analysis, we use the World Resource Institute Aqueduct product, which gives global flood hazard maps. So that's depth of flooding at different return periods, different likelihoods of floods now and into the future under those different climate change scenarios that I showed earlier. So there are global models that give current and future pictures of the hazard side of things, so the flooding. There are also extremely good global data sets on the networks. So we've used OpenStreetMap roads from trunk and motorway down to primary, secondary and tertiary roads, which gives very good coverage of the road networks and indeed the rail networks within the study countries. Plugging that together into the models and tools that we've developed has allowed us to produce some open source analysis and open data results. So there are, on this resilience analysis, there are two outputs that I'd like to highlight from this kind of technical data point of view. So on the left is the code base. So for any Python programmers or GIS, Geographic Information Systems people, or your friends who are into these things, this is the link to visit, which provides the codes that do the analysis. So that take those data sets, bring them together and allow us to calculate the various insights and results. That's on GitHub, which is a website for code sharing. And the full link is there, NISMOD, East Africa Transport. On the right, we've also packaged our analysis into a web-based tool, which is essentially an interactive map to view the data sets that we brought together and the risk and resilience and adaptation results that we've calculated. So I think I'm doing okay for time. This is the moment where I try and do a live demo of the tool. So hopefully you can see my web browser where I've gone to that link, East Africa Infrastructure Resilience.org. where the homepage gives a brief introduction to the project, and the substance of the platform is this interactive map, where we've brought together the OpenStreetMap roads. So here I'm showing primary roads, but we can bring in trunk and motorway, and then with increasing detail, secondary roads and tertiary roads. There is data in OpenStreetMap that could go beyond this, but for our focus on long distance transport networks, this was the level of detail that made sense to us. We can also bring in the rail network and the key ports and airports, which give international links for freight. That's the OpenStreetMap data. The hazard data, as I mentioned from WRI Aqueduct, gives you these maps of flood hazard depths. So let me just spend a moment to show you what this looks like. Let's pick some area in Tanzania where there's some river flooding. So here you can see the grid cells, the sort of pixelated outline of the flood, and the flood depth that has been calculated by their model. And this is a 1 in 100 year flood, so that's the sort of a 1% chance of happening in any given year in present and baseline. So you can explore here the different return periods, so more or less likely floods, and look across present and future. Let's take that off again for the moment. So those are the key input data sets. And if we go to the risk tab, we can look at one of the key outputs, which is that calculation of direct damages to roads. So here we've got our road network. In grey are those roads which aren't damaged, and in shades of yellow through dark red to black are roads which we expect to be damaged with higher frequency or deeper floods. So it's leading to higher costs of expected annual damages. So from this map, you can get the overview of where floods are affecting transport networks, and you can drill in. So if you click on any one of these roads, it brings up the details of the road. So any attributes that we know about it. And I won't spend too much time right now explaining all of these, but the change in expected annual damages over time between the different climate scenarios, so that's the direct damages to the road, or the economic losses, which are the wider impacts to the economy, where we've calculated freight flows and then said, okay, if this road is disrupted, where will freight have to travel longer and therefore a more expensive route to get to where it's going? Or maybe some value of freight is just lost because it can't go to its destination because that road was the crucial link and it's now been cut off. So those are the major sort of risk outputs that are calculated and showed in the viewer. And I would say this is starting to show how the tool can be used for prioritization or initial screening of roads that you might be interested in taking a closer look at. This is not a detailed engineering analysis, and it doesn't take you anywhere near sort of full project initiation, but it should be giving a good overview and a good sort of indicator to focus next efforts. I think I've got 5 minutes or so do jump in if I need to stop, but let me just show the final tab I wanted to show here, which is the adaptation tab. So this is, once we've calculated risks and damages, we introduce those different adaptation options, the swales, the flood walls, the embankments. And here I've selected primary roads under RCP 4.5, which is that medium emissions scenario where emissions stabilize throughout this century. And I can look at the different adaptation options, such as rehabilitation of drainage. And I can look at the cost benefit ratio, which is the sort of initial cost benefit ratio we've calculated for each of these roads. And again, in shades of yellow through to dark blue, we see the most cost beneficial roads. So this is purely in terms of risk reduction. So purely in terms of avoided damages by improving drainage. We'd expect the damages to this road to be reduced. And so we'd expect to get a benefit from doing that drainage rehabilitation or doing that intervention. This then also gives you a chance, if I switch back to asset type after selecting one, so come up with the individual view on that road and the full details as we've calculated out those adaptation options under each of the climate scenarios for each option. There's a cost that we've evaluated for the length of road that you'd need to intervene on, and an estimate with an uncertainty range of the avoided risks. So this is again drilling right down into an individual stretch of road as it's been represented in our analysis. There are more important caveats. One is that this is essentially an undefended analysis. So we've not had information on the current protection status of any of the roads. So we've assumed that they are undefended and that then each of these potential interventions would make a difference to the risk that they're experiencing. It may well be that many stretches of road are already protected to some extent. So that's another thing you would need to bring in when you come down to the individual asset level. But to repeat myself briefly, this is aiming to give a high level overview, initial prioritization screening, and really to present very clearly and in full detail the results of the analysis that we've done. Last piece, just to show here, is the reference to the data sets that we've used. So there are links from here to the source code for this website itself, the source code for the analysis code, and the various, well, particularly the hazard data and the infrastructure network data from OpenStreetMap and from WRI Aqueduct. That is my brief presentation of the tool. And with that, thank you very much. I think there's an opportunity now for short questions. Yeah, the one-line summary is that there is very good global open data, and that with some of these tools, we're building towards actionable insights and openly shareable results that should be providing a step towards project screening or risk overviews that gets us a step further towards sustainable and resilient long-distance transport networks now and into the future. Thank you very much.
Thank you very much, Tom. This is really very useful. I've just checked to see if there's any question in the Q&A app. There's none so far. So let me use the chair's prerogative to just ask a few basic questions to start with. The tool that you've just shown, is that openly available to anyone? Is there a link? I think there was in the Q&A someone asking if you could share the link. So that would be the first question.
Yes, it's openly available. To some extent, it's work in progress. So we're still going with the project. So there may be some small changes coming along. And that means there is also some opportunity to provide feedback that we might be able to act on. And yes, I'll drop the link in the chat in a moment.
Okay, thank you very much. Now, in terms of the data that you've used, open source data, we all appreciate that in low-income countries in particular, data is something that is often not readily available, and if available, it may not be reliable. So how accurate or how reliable, perhaps is a better word, these open source data that you use, considering the countries that we are talking about?
So the short answer is they're fairly good. To touch briefly on both the hazard data and then the network data, the hazard data from WRI Aqueduct gives an indication of flooding at a reasonably fine scale. There are better flood products out there which are commercially available and have global coverage. Here we picked this because it was free and open and it had that projection into the future. So it's one of the few, I think it's the only global open data set of flood hazard mapping which has climate change projections built in. So there are global flood maps for the current condition, which would be worth doing sensitivity and comparison against. And as always with global products, like global modeled products, there is more work that could be done if you were in country and did some validation based on historical events and so on. So that's something that would need to be done, taking it down a step and doing further analysis. On OpenStreetMap, I think the coverage is very good, particularly when you're talking about primary through to secondary and tertiary roads. There are definitely gaps in terms of rural roads or more local roads, but there are various studies that show good completeness of OpenStreetMap road coverage in particular, and there are continual campaigns and efforts to improve coverage, particularly in response to humanitarian crises of various kinds. So humanitarian OpenStreetMap team is an excellent actor in the field, which drives data collection and data improvement and validation in places all around the world.
Tom, we have two questions that have come up, and John Hine, a good long-term friend. Do you want to read them, Tom, or shall I read them out to you?
I can see them. So John Hine's question is, does the road data you use draw on the standard road maintenance data collected by road authorities? No, we haven't used in-country road authority data. That would be our approach, were we to engage sort of directly with an individual country. We've taken this regional approach in order to sort of prototype a globally workable open approach. Secondly, have we considered road landslides, for example, in mountainous terrain, not river-based? No, not in this project. Landslides are an important cause of road failure, typically linked with surface water flooding, which is not covered by the aqueduct product. There are surface water flooding products, and I'd be interested particularly in any global open landslide hazard data set, because I'm not aware of one. Yeah. Was there another question you wanted to pick up, Henry?
There's also one from, I think you've answered the one about the link and the use of the tool, but there's one from James Evans.
What are the key barriers to data owners making their data open, and how do we as a sector best overcome these? It's an interesting question. It comes down to questions of governance, regulation, sometimes political will. And I think the answer will vary depending on the kind of data. So here broadly, I'm mostly talking about the geographical description of the road network itself, which has, as far as I can see, no sort of privacy or personal information concerns, which would often be a barrier to sharing data, rightly so. So then there needs to be a policy or regulation decision which leads to that data being published and updated by an official department. So yeah, broadly, I see open data sets coming from governments where there has been a law or regulation requiring the opening of that particular data set. So it's coming through that route.
Thank you very much, Tom. Obviously, quite a number of questions still, but in the interest of time, I think let's move to the second presentation. I hope that you're going to stick around till the end, because there will be a longer session for others to join and ask questions in person as well. So over to the next presentation, which will be by Philip Kraus from Go Metro, who is working on the HVT project, Africa Urban Mobility Observatory, or AUMO. Philip will begin by summarizing his project and then make the presentation. Over to you, Philip. Thank you.
Thanks, Henry, and yeah, thanks, Tom, for that very interesting presentation as well. It's going to be a tough act to follow. So yeah, I'm going to be presenting on the Africa Urban Mobility Observatory, also known as ORMO or AUMO, or there's many ways of people saying it. I'm a transport engineer and have been project managing this project for the past 2 and a bit years. And I'm going to dive straight into the presentation so I can explain more about the project. I'm sure some of you on the call are familiar with the project since it's been running for quite some time. But yeah, I will. Sorry, just give me one moment while I figure out how to share my screen again. Okay, I think my screen should be visible to everyone. Great. So first of all, this project, as indicated previously by Henry, but both these projects are part of the HVT program, which is funded by UK aid. In terms of the consortium partners, Go Ascendal and Go Metro has been leading this project with the support of UN Habitat, Wuppertal Institute, UEMI, and then independent subcontractors Heather Allen and Gail Jennings. In terms of the research questions that we aim to address, the first question was with regards to policy levers, and the question was, what are the main levers for transport mode share, and what is the role of data, and what cities have achieved high or low transit ridership, cycling, etc., and what factors policies explain their differences. Then on big data technology, the question was, what are the opportunities and risks of big data applications in the global South cities? And then finally, the question regarding informal paratransit was, what is the role of informal paratransit in the global South, and how to enable transition towards clean, affordable, and efficient transport solutions. So what, from the Go Metro and Go Ascendal side, our focus was on developing an observatory ecosystem in which we developed a range of data collection solutions, mostly based on telecommunications technologies. So essentially our aim was to try and reduce the cost associated with mobility data collection, which is typically cost prohibitive. And one of the reasons why sources of data, especially in sub-Saharan Africa and the global South in general, is often lacking. So what we did under the ORMO project was to identify 6 research cities. So those were Blantyre, Gaborone, Kigali, Kinshasa, Lagos, and Maseru. And then our colleagues at the Wuppertal Institute supported with the identification of suitable indicators, which our data collection tools would then collect data on. And then what we did was proceed to develop a range of data collection instruments, as far as possible using existing technologies. And I will go into a lot more detail about each of these different data collection techniques. In parallel, we also developed the web data platform, which you can see over here to the right of the screen. And if there's some time, I'll give a brief demo of that as well towards the end of the presentation. And you can access that via the link that's indicated there. So it's mobility.observatory.goafrica.org //start. So you can go there right now. It's live, up and running. And the idea is that the data that we collected using these various instruments, as well as understanding, the costs associated with collecting data through these different methods, the idea was also to build this data set, at least the start of this data set, which could potentially be expanded going forward through further data collection rounds and by adding additional cities into the platform. But essentially it would support transport decision makers identify how best to make use of their limited budgets to address the needs of the people in their respective cities. So let's move on to the first data collection method, which was just conventional field surveys. So this was, we chose to do field surveys with basically just intercept surveys where enumerators would physically go to busy transport interchanges with a tablet or a smartphone and conduct interview style multiple choice questions. And this was to basically have a benchmark, since well, there were two reasons for the conventional field surveys. It was one, to have a benchmark in terms of the cost, because we wanted to understand, well, what does it actually cost to conduct a more conventional survey, which is generally perceived to be, or is understood to be, more costly. But also, since some of the data collection methods that we developed were reliant on various degrees of cell phone technology or mobile telecommunication technology, we knew that there would be some demographic profiles that would be excluded as a result of not necessarily having access to that technology. So we also needed to ensure that we had a way of reaching people from all demographic profiles as far as possible. So as mentioned, this was a multiple choice style question administered via smartphones, where passers-by were intercepted at public transport or busy transport interchanges and activity centers. And there were 3 campaign cycles per city. And here below in this table, we see 5 of the cities. We've excluded Kigali from the data set because we were not able to conduct the data collection campaign in 2022 due to various challenges in getting the necessary authorization, especially when it came to the technology-based solutions. But as you can see over here, we had the total number of respondents. The column over here you can see were mostly in the 400s, and then after cleaning the data, which was essentially a process of just removing responses that seem to be perhaps contradictory. For example, if someone said that they were unemployed and yet they also indicated in the survey that they travel to work 5 times a week, when there were those kinds of anomalies, then we would remove those entries. And then here we see the survey team and consumables cost for the survey round was around 1,800 pounds, British pounds. And in terms of the effective unit cost, which is dividing the total cost of the campaign by the number of cleaned surveys that we end up with effective unit costs ranging between 3 and 7 pounds per survey respondent. The next method that we deployed was USSD surveys. USSD is unstructured supplementary services data. It's a GSM-based communication protocol and is very common, especially in sub-Saharan Africa and elsewhere in the global south. It's commonly used to load mobile airtime, and also to do money transfers and enter competitions. There's all sorts of ways that USSD is used. And the main point about, or the main advantage of USSD is that it's compatible with all GSM devices, pretty much regardless of age. So even a 90s 2G GSM device, like a Nokia 3310, for example, is able to communicate via USSD, and it allows the device to communicate to have an interactive communication with the server. So you're almost emulating an internet kind of system through this USSD channel. There are some limitations associated with USSD, such as they are session-based. So there's a time limit. They can only last a maximum of between 120 and 180 seconds, depending on how the mobile network operator has set up the system. There's also a character limit of 160 characters per screen. And this also depends on the mobile network operator, but it very rarely exceeds it. Sometimes it can be a little bit less. And then also there's the option of having using shared USSD channels, or to develop a dedicated USSD channel, which comes at additional cost. But the advantage is that with a shared one, often the user is charged for the session, whereas if you have a dedicated channel, you have control of that, and you can actually then have the bill come directly to you, or the survey manager. To initiate a USSD session, the user must dial the code. So what we did was to recruit respondents. We sent out spatially defined targeted SMSs. So that was, about 100,000 SMSs per city. We gave the mobile network operators a sample plan, basically a list of a number of SMSs that we wanted to be sent out to their subscribers in the various zones of the city. And the mobile network operator then sent it to their subscriber based on their location and proximity to the various cell phone towers. In terms of the key findings from the USSD sessions, we were able to conduct these in Blantyre and Lagos only. We had some issues essentially the cost of conducting USSD sessions, USSD surveys was found to be prohibitively high in some other cities. So only Lagos and Blantyre were successful, and we used the TNM and MTN networks respectively. As mentioned, we sent out about 100,000 marketing SMSs, and we offered a 20p incentive as an airtime voucher to those who participated. In Blantyre, we had almost 2,000 participants initiating surveys. However, you can see that the drop-off rate was quite severe. So those that were able to get to 80% through or complete 80% of the survey was 448, and 100% of the survey was 367. And this was due to the session timing out. So as mentioned previously, that 120 to 180 second timeout is a critical factor when designing a survey for USSD. One really needs to be careful and ensure that you have a survey that's not too long. Otherwise, there's a good chance that people are going to get timed out before they've actually completed the survey. In Lagos, we came close to 1,000, and then the number of completed surveys to 100% was 149. So in terms of the costs, there's certain costs associated, certain once-off setup costs associated with USSD. So you have to set up the channel. And here you can see in Blantyre, that was about 1,167 pounds, whereas in Lagos, it was closer to 600 pounds. Then there's also campaign cycle costs. So every time you run a campaign, you also have costs associated with that. So that'll be on top of that once-off cost for the first cycle. And then every cycle after that, you will only pay that cycle cost. You won't be paying once-off setup costs. Then also, in terms of the airtime incentive, I mean, of course, this is, you can set that wherever you wish. And you can also limit it to, only the first 1,000 participants or the first 100 participants. It's really up to you. But for us, we offer this incentive to all participants that I think it got to 80% through of the survey. Then those people got their incentive, and then the rest did not. In terms of the cost per participant, the resultant cost for the phase one, which is now including the setup costs and the campaign costs, we were slightly higher than the conventional intercept survey in Blantyre, and quite a bit higher for Lagos. But this is largely due to the fact that in this calculation over here, we only consider the 100% complete surveys. If we were to have reduced the length of the survey questionnaire, and we would be able to get everyone who attempted to participate be able to actually complete the survey, then you see quite a big reduction in the cost per participant. So £2.16 for the first phase, which includes that setup cost, and then thereafter, for every phase afterwards, it would be £1 per participant, and similar figures for Lagos. So that's around 4 times less than the conventional survey method. We also conducted WhatsApp surveys. Here, with WhatsApp, there's no character limits or time restrictions associated with it. And also, like with USSD, the participant needs to initiate the session. So we combined in the marketing SMS that we sent out, we had links for WhatsApp as well as the USSD dial-in code. But the one difference was that we did not offer an incentive to WhatsApp participants since our budget was constrained. So we took the decision to not offer the incentive. And as a result, well, at least I believe that that's the main reason why we ended up with so few participants. But in Blantyre, we had only 15 participants attempting to start a USSD session, and 52 in Lagos. And both of those had a kind of dramatic drop off once they reached the 80% mark, and 100% was even lower. And while there was no timeout or time limit associated with this questionnaire, what I suspect is that the questionnaire was simply too long for people to continue. They didn't want to spend more than 3 minutes or 5 minutes on the survey, so they dropped off, out of voluntarily rather than being cut off by the system. So what this resulted in, while the setup costs were very low, much lower than for USSD, and the campaign cycle costs were similar to that of USSD. And so the airtime incentive over here is, you can ignore this for the actual cost per participant, because we did not include it. These figures over here, the 257 and 54 pounds per participant, are based on no incentive. But based on the very low numbers of people who've actually participated. But if you look at phase 1 and phase 2 targets, where we assume that everyone receives an incentive and also is able to complete the surveys as a shorter survey, then you do end up with very competitive per unit costs, as shown over here. The final survey method that we deployed was user movement analytics. This is a smartphone-based solution, which asks volunteers if they'd be willing to have their devices tracked for a period of 7 days. It was available as an Android standalone app, which could be downloaded from the App Store. And as you see over here on the right of the screen, it shows the trace of someone who's traveling around Cape Town. So that just gives you an example of what's going on in the back end of the system. So in terms of the methodology and findings, UMA must be voluntarily installed on a user's device, and participants were recruited through a Facebook marketing campaign, and they were offered an entry into a mobile airtime lucky draw as an incentive. The marketing campaign lasted for 5 days, and participants were tracked for 7 days. Now, unfortunately, the turnout on UMA was very low. As you see, Blantyre, we had the most user registrations, but only 24 of those 60 completed the full 7 days of tracking, and the rest of the cities were far lower. The campaign costs overall, in terms of the marketing messages, was actually relatively low, but the effective unit cost was high, simply because we had so few people participating. And then finally, just a summary. As you can see over here, the yellow highlighted are the indications of what the lowest cost survey methodology would be per city, assuming that the WhatsApp and USSD surveys could be cheaper if we were to have people completing them right through to the end. So WhatsApp and USSD could potentially be affordable, but unfortunately, obviously for Gaborone and Kinshasa and Maseru, we were not able to conduct WhatsApp and USSD surveys due to various issues, especially surrounding the USSD and the sending of marketing messages, which could likely be overcome, but it would require some negotiation. So yeah, that brings me to the end of my session. Please let me know if anyone has any questions.
Thank you very much, Philip. Very interesting presentation as well. And although we don't have any questions yet, I'm sure we will get on the Q&A app. I have a couple of questions to start with. First one on big data. I didn't really hear much on use of general big data, for example, mobile phone tracking, anonymous mobile phone tracking, which has been used elsewhere. Is that possible? Is it useful for a start? And I assume it would be almost cost-free if the MNOs can provide that kind of data. That's the first question.
So no, certainly it would be very beneficial. We did approach many mobile network operators and ask if we could have access to the data that they sit on mounds and mounds of big data. But there was a clear or general reluctance to proceed to share it. I mean, there was interest in discussing the possibility of sharing it, but it seems that they're not quite sure. They want to monetize it essentially, and they're not quite sure what to charge for it and who to share it with. And after many discussions, it just, unfortunately, we didn't get very far with actually obtaining any of the data. And of course, the data itself is also very sensitive. So if they do share the data, they do need to pseudonymize it, or make it, convert it into a different format that we can't see any specific details of the individual subscribers.
Yes, thanks. As a follow-up question, really, what you've shown are, if you wish, real-time data collection. How useful are these for long-term planning? Do you find consistency in user or traveler behaviors from between years? So somebody traveling today, particularly in low-income countries, may not be having the same travel pattern in a year's time. So it's really the reliability of data collected in that form.
Yes, certainly. And that's one of the reasons why it's so important that more affordable methods of data collection are established, so that every year or however frequently it's determined to be appropriate, the data can be renewed. So that was really our main goal, was to try and identify what could be more affordable ways of collecting this data. And as you saw, those setup costs, those are the once-off costs. You can maybe in year one you spend a little bit more, but then year 2, 3 onwards, ideally your campaigns get they're more affordable.
Thank you, Philip. We do have one question in the Q&A from John Hyde. I'll leave it to you to read it out. Philip, go over to you.
I see over here your survey costs appear very low compared with conventional surveys. A rural survey could cost $100 per household, which is great. But how many questions do you typically ask? Okay, so the questionnaire comprised around 20 to 25 questions. So they informed the indicators that were listed in one of my earlier slides. So it's probably not nearly as extensive as the surveys that you're referring to, which would partially explain why they were more affordable. Also, we were not going into, we were not going to people's houses. So there were no travel costs involved. We only intercepted people at activity centers where there were a lot of people who could be surveyed in a fairly short space of time. So that obviously resulted in the cost being considerably less than what you've indicated here in the question.
Thank you, Philip. I'd like to bring back Tom Russell, because this is a question that is relevant, I guess, for both of you. What are the big challenges for making sure that data is being used effectively for transport development, particularly in these low-income countries? We may do all these surveys, get good data, but will they actually be used? Will they be used for planning and implementation of, in this case, infrastructure projects? Maybe Philip first and then Tom.
So it all comes down to political will, I guess, and also capacity. On the OMO project, what I haven't really discussed, there are parallel activity streams which have been running, and one of them has been led by UN Habitat, which has been the development or the co-development of action plans with 2 of the 6 case study cities, so it was Kigali and Blantyre. And especially in Kigali, there's definitely strong political will to make use of this data and to continue collecting data moving forward. And also they did indicate that they do want to, as part of the action plans, one of the actions which they said was necessary was to ensure that the academic institutions are geared towards supporting. Well, they have modules that train students to support the collection of mobility data and analyze the data moving forward.
Tom?
Yeah, I would echo Philip's points. So I think all of those are absolutely relevant. Maybe particularly thinking about our cases and the studies that are ongoing, engagement and time and resource and capacity within the sort of the actor network of infrastructure operators, different sections of government, funders and donor organizations, needs to be well supported and stitched together, and that takes lots of different people and it takes time. Two things going forward: there's the Climate Compatible Growth Research Programme, also funded by UK FCDO, UK Aid, which is sort of a sister programme to HVT, and there are ongoing projects in Kenya and Zambia, I think, working on energy and transport. So there are other strands to that, but also some of the transport resilience work that we've looked into. And GCA, the Global, I always forget the C, Commission for Adaptation, are working with University of Nairobi to look at transport resilience in Kenya. And that's a project that's led by University of Nairobi that we will likely have some input to as kind of consultants or support, but it's that getting ourselves further out the picture, partly by making our tools more reusable or reproducible and easier to use and easier to transfer, but partly by putting the resource in the hands of people who are closer to the action. That's a good direction to take things.
Thank you very much. We still have a few minutes, so if anyone wants to add to the Q&A, that's fine. But again, I'll use the chair's prerogative just to ask one question in terms of dissemination and getting ownership of this very useful data from my perspective by governments in low-income countries. What are your plans for disseminating this and engaging governments to actually take ownership and continue? I guess it will be different parts of government, obviously, maybe city authorities or maybe ministries in the case of infrastructure. But do you have any plans, and what would those constitute? Tom first and then Philip.
Yeah, so I think I touched on them in part of my answer just now. So we have run our final series of workshops for the project where we spoke with agencies in each of the 4 countries. And that's in the early stages of discussion of follow-up work, but that would be in particular organizations or agencies like Kenya Highway Authority, KENHA, or the Zambia Roads Authority, or Tanzania. There's the Tazara Rail and Tanzania Rail, both or either. It's early days in terms of concrete plans to move on and engage more directly with them. But yeah, things taking shape.
Thanks. And Henry, from our side, I mean, I think, yeah, as with pretty much, I think all the HVT program or projects, stakeholder engagement and dissemination is very much baked into the methodology. So, we've been engaging stakeholders from day one in this project and have continued to do so. And moving forward, essentially the action plans that are being co-developed now will definitely support the 2 beneficiary cities and hopefully inspire the other cities that have also participated in this program or this project to follow suit. I was in Kigali a few months ago where we held a workshop to basically collect data for the co-development of the action plans and to also present what we've done up till that point. But there is a strong desire to carry this research forward and to continue the efforts that we've put in place and really continue collecting more data and bigger data, better data.
Okay, very good. We actually bang on time, so to speak, right at the top of the hour. So I just checked if there are any more questions in the Q&A. There appears to be none. So I want to start to conclude this session by, first of all, thanking Tom and Philip for their presentations, and to all of you, of course, for attending this Research Exchange webinar.